Hello friends, this video on Equilibrium Part 10 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's talk about heterogeneous and homogeneous equilibrium. So what is heterogeneous and what is homogeneous equilibrium? It's equilibrium in which system has more than one phase. That is called a heterogeneous equilibrium. In most of the case, we have more than one phase, and the one which has only one single phase, maybe everything is solid or everything is gas, everything is liquid, in that case it is homogeneous. But in equations or equilibrium where you have some of the components in aqueous, some of them are liquid, some of them are gas, they are called heterogeneous equilibrium. For example, in this case I have a water vapor, right? So here if you have this water vapor was the liquid, it is an equilibrium with water vapor in the gas. So if you see there are two phases here, liquid phase and the gas phase. You keep the water bowl in a box, you will see that it will evaporate on its own, and then you will have water in the gas form in this box and water in the liquid form here, and there will be an equilibrium after some time. So in this case, if you see, there is a gas phase and the liquid phase. So this kind of system is heterogeneous equilibrium. For example, this as I told, this is the example of heterogeneous equilibration. And as we've already discussed, for pure solids and pure liquids, the molar concentration is constant. So we'll take the value as constant, right? And this one more example we have is, if you see CaCO3 was solid, it is in equilibrium with CaO, solid, and CO2. There are two solid here, one gas here. So when you write the Kc, you ignore the CO and CaCO3. Now let me take one example of homogeneous equilibriums. If you see this example, I have everything is in gas form. Example here, maybe I have 2H2 plus Cl2 all in gas gives 2HCl. Everything is in gas, all in gas. So maybe if you see in this case, everything is gas. Such kind of equilibrium where all the chemicals, whether they are the reactants or products, are in the same phase, that is called homogeneous. And the one in which there are more than one phase, for example, my water evaporates, we have a liquid phase, I have a gas phase, this is called heterogeneous equilibrium. We'll take some example of heterogeneous equilibrium. The value of Kp for this reaction, carbon dioxide gas plus carbon solid, gives carbon monoxide. If you see, this is gas, this is solid, this is gas. So there are two different phases here, solid and gas. So it's a heterogeneous equilibrium. For this equilibrium, the Kp value is 3 at 1000 Kelvin. If initially the pressure of CO2 was 0.48 and the pressure of CO was 0 bar, we have to find the equilibrium partial pressure of CO and CO2. So let's solve this example. CO2 plus carbon gives 2CO. And this is in gas. This guy is solid and this guy is gas. And Kp is given 3 at 1000 Kelvin. So at T is equal to 0, they say that the initial pressure of carbon dioxide was 0.48 bar. 0.48 bar. And this we can ignore, and this was 0. At T is equal to equilibrium, let's suppose 0.48 bar becomes 0.48 minus X. Since X is used, it will form 2X. Why? Because this is 1, this is 2. For CO2 it is 1, for CO it is 2. So if X CO2 is used, 2x CO will be formed. Correct? So let's write the value of Kp. Kp will be what? Concentration of CO, partial pressure of CO to the power 2 divided by partial pressure of CO2 to the power 1. This carbon solid we can ignore. This value is given 3. So you solve this equation, you get x is equal to 0.33. That means partial pressure of CO2 is what? 0.48 minus x, that is minus 0.33. That is nothing but 0.515 bar. And partial pressure of CO is what? 2x. That is what? 2 into 0.33, that is 0.66 bar. And that is nice. Easy question. See, we have done this kind of question in the past also, where it's given that initial concentration of pressure is some value, and in equilibrium you assume that some x is consumed and respectively 2x or 3x is formed based on the stoichiometric coefficients, and then you find the value of Kp, put this equation, solve it, get the value of x, and then you have all the answers. See, the question says the reaction between N2 and O2 takes place. With this reaction, N2 plus O2 is equal to 2N2O, and the mixture has 0.482 mole of N2, 0.933 mole of O2 in 10 liter reaction vessel at a temperature for which Kc is given. We have to find the composition of the equilibrium reaction. Two things to note here is, first thing is the volume of the flask is 10 liter. Second is the Kc is very small. Since the Kc is very small, that means you will have more stuffs on the reactant side. The product side will have almost nothing. So if you have 2N2 plus O2 gives 2N2O. So let's suppose initially it was 0.482 and this was 0.933. I assume that T is equal to equilibrium, some x mole of this is used. So this is 0.482 minus x. If x mole of N2 is used, x by 2 mole of O2 will be used, stoichiometric thing. You can see that, minus x by 2. And if x mole of N2 is used, x mole of N2 will come. So let's suppose this is my equilibrium thing. But since this Kc is very small, x will be very small. Why? Because since the Kc is very small, that means the reaction hardly happened. X is very small. So in that case, my N2 concentration will be what? It will be 0.482 is the number of moles. Minus x is the number of moles. By liter is the 10 liter. And this will almost be equal to 0.0482 mole per liter. You can ignore the x. X can be 0 here. Similarly, the molar concentration of O2 will be what? 0.933 minus x by 2 divided by 10. You can ignore this part, so this becomes 0.0933 moles per liter. Similarly, the concentration of N2O we have to find. That is x. We can't ignore this part now. X by 10, right? Because if you make it 0, doesn't make any sense, right? Even if it has some value, it will have some meaning here. X by 10 mole per liter. So with this, if you find Kc will be what? Concentration of N2O to the power 2, that is x by 10 to the power 2 divided by concentration of O2. O2 is what? 0.0933 mole per liter, and then concentration of N2 to the power 2, that is 0.0482 to the power 2. And this value is given as 2 into 10 to the power minus 37. So if you solve this equation, you will get the value of x to be 6.6 into 10 to the power minus 20 mole per liter. And that is the composition of my N2O. Other thing, composition I am assuming it to be same. Only N2O composition was something which is not known now. It will be x by 10 So you divide this by 10 and that becomes the concentration of my N2O in equilibrium. So 2NO react with Br2 to gives NOBr, all in gas. When 0.087 mole of NO and 0.0437 mole of Br2 are mixed in a closed container at a constant temperature, 0.0518 mole of NOBr is obtained at equilibrium. Find the equilibrium amount of NO and Br2. Similar step, similar approach will find. We have NO, we have Br, it becomes 2NOBr. Initial state we have 0.087 mole of NO and 0.0437. T is equal to 0. At T is equal to equilibrium, this becomes 0.087 minus X. This becomes 0.0437 minus X. And with X is used, since it is 1 here, 2X will come here. Sorry, this is 2N. So if it is X, this becomes X by 2 and this becomes X. Correct? It is 2NO. So 2NO gives 2NO Br, so XX, and it is Br, so it is X by 2, right? Because we have coefficient 2 here, we have 1 here, we have 2 here. So if X moles of NO is used, X by 2 moles of Br is used, and X moles of NOBr is formed. And the value of X is given. That is 0.0518. So if X is given, I have everything. Concentration of NO is what? 0.87 minus X, that is minus 0.0518. That is 0.0352 moles per liter is not given, moles I can just say. Let's assume everything is in 1 liter now. So it will be mole per liter. Similarly, the concentration of PR is what? 0.0437 minus X by 2, that is 0.0518 by 2. You solve this, you get 0.0178 moles per liter. Now I have concentration of NOBr and NOBr also. So I can easily find Kc, but not required. I have to just find the amount of NO and Br2. So it will be this much moles. Don't assume the liter thing because it is not even asked. So we can just say that I have 0.0518 moles of NOBr, 0.0352 moles of NO, and 0.178 moles of bromine gas. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.